Thank you. Thank you. Well, it's a pleasure to be here tonight. I will try to project as loudly as I can. I'm going to show you some things that I suspect many of you have not seen before or has been presented to you before. You've heard all the term politically correct. That is something that I am completely not. And so I'll apologize up front. I mean no offense to anybody. And none of this should be offensive, by the way. But I just say that because we're in a very tight-knit society these days, and it's easy for folks to take offensive things. And that's part of what I would argue is the problem with how we're attacking our problems today. We're getting too defensive, and we're not just open to whatever the truth is, whatever the data is. Truth should have to have no defense. It is whatever it is, and that's what we need to deal with. So I will present you what I believe is truth. It doesn't mean that there isn't debate, and debate can be healthy and respectful. And without further ado, I'm going to jump into what I hope you'll find an interesting dialogue. I'd like to start with a few warm-up questions. And a lot of this is going to be interactive just by raising your hand. So if you do have questions, please write them down. We'll have a time for questions. But many of the way I'd like to present information is through a dialogue of your raising hands. So you will need to be able to read the questions and to commit with your hand. No one is going to be called on to speak. Who is known for saying, "Risk is our business"? Hopefully all these names are familiar to you. Risk is our business. How many say Winston Churchill? How many say Adolf Hitler? President Obama? Captain James Kirk? All of the above. Okay, is anyone, by the way, absolutely certain they know the answer to this question? Okay, well, the actual correct answer is D, and the episode was called Return to Tomorrow, original series. It has no relevance other than the idea of risk is actually a very important concept. You'll see how that ties in later. Warm-up question number 2. Who is known for saying the following phrase, "I am that I am"? You can all see the choices. Hopefully all of those names are familiar to you. How many vote Mao? How many vote for Popeye? God. The Klingon Empire. All of the above. Okay, this one is a bit of a trick question. The actual correct answer is C, God. Popeye, remember, said, I am what I am, and that's all that I am. Not I am that I am. Very close. You're wondering how that relates to sustainability. Give me a moment. Okay, warm-up question number 3. The line must be drawn here, no further. Who said it? Arafat? Does everybody remember Arafat, by the way? He's passed away now. He was the leader of the Palestinian folks. This was a true event, by the way. Mubarak, the recent events that hopefully you've all seen on the news. Churchill, who was head of England in World War II. Or another Star Trek reference, Captain Jean-Luc Picard. Okay, how many vote for A? B? C? Okay, and D? Okay, interesting. The actual correct answer is a Star Trek reference. Jean-Luc Picard. And the last warm-up question. Which unit of time is not fundamentally based on an astronomical event? That is something that can be measured and is repeated. Hopefully that's clear, the question. These are the four choices. One is correct. How many vote for year? Month? Week? Day? Okay, the majority of you got it right. The answer is a week, and let me tell you why. A year, you know, is the Earth makes one revolution around the sun. 1 year. The month, the original concept of a month, was the moon makes one revolution around the Earth. A day, the Earth rotates one time on its axis. The week is actually, even though it's 7 days, it could have been 6 days or 8 days. Why 7? And that actually came out of Judeo-Christian biblical concept of the 7 days of creation. And it's known actually as the creation cycle. But a week actually came to us from a non-astronomical event. It's the only time frame we use, by the way, that has that attribute. I know you're wondering, how does any of this relate to... Okay, let's jump into it. Sustainability question number 1. The big one. I tackle the big ones up front. Is the planet Earth running out of water? Huge question, right? Hopefully you've all thought about this. These are the four choices. We're either running out of all kinds of water, we're running out of just fresh water, we have water, but it's getting polluted, and so we're running out of the usable water. No, we're not running out of water, or both B and C. We're running out of fresh water and this other usable water because we're polluting things. Everybody understand? You know how you're going to vote? Okay, how many say we are running out of all kinds of water? Okay, B, running out of fresh water only. Interesting. C, we have water, but it's getting polluted, and so we're running out of this usable water. Okay, D, no. Okay, and E, both B and C. Okay, that is by far the majority answer in the classroom, B and C, and that is actually the wrong answer. The correct answer is D. Now you might be thinking, well, how can this be? I've heard so much about the water issues on the planet. 2 billion people do not have enough fresh water to drink every single day. 2 billion people. And here I'm saying we don't have a water problem on the planet. And the distinction is this. From a planetary view, we live on a water planet. If I were to ask you, take this cup of water in here, and go out and destroy this water. Do you know a way to destroy water? You can burn it, but it becomes a water vapor, and then when it condenses, you're going to get 100% of it back. You can pollute it, you can mix it with something else, but then we can burn it and evaporate it and get 100% of the water back. Do you know of any way to actually destroy water? You can separate it, hydrogen and oxygen, but then you can combine it back. You'll not only get water, but you'll get energy. Which, by the way, is how a fuel cell works. So we don't even know how to destroy water. Okay, we live on a water planet. So from a system scale, from a planetary system scale, we are not running out of water, nor would we even have the knowledge to run out of water. We don't know how to get rid of it. And I'm not saying we would want to get rid of it, but I'm saying if we did want to, say tomorrow science said, water is now the problem. We don't know how to get rid of it. We can change its state, we can separate it into its elements, but we can always get 100% of it back. Even the most polluted water we can get back, the water. We still have the pollution, but we can get the water back. So, knowing that, why are 2 billion people don't have enough water to drink? And the answer is, we're going to discover in a moment. But it's not because we don't have enough water. And by the way, you might say, well, wait a minute. We have ocean water, but we don't have the good drinking stuff. But we already know, technology-wise, how to turn any type of polluted water or ocean water into drinkable water. One of the projects that I worked on called Montera, it has its own reverse osmosis plant. It's been running since 1998 for 12 years. It takes salty water, turns it into the purest type of bottled water you could imagine. Fits in a small barn, the plant. We've had submarines that take ocean water and what they call flash distillate the water. They take ocean water and they raise the temperature on it, form steam, and then they let the water condensate back. It's pure water. The salt's left over, but they have pure water. We've been doing this for decades. Technologically, we know how to make fresh water out of dirty water. But there's cost, there's energy involved, and there's politics. Okay, second big question. We touched on water. How about energy? Is the planet Earth running out of energy? Okay, here are the choices. The science is clear on this. B, there's a fixed amount of energy and we're using too much. Therefore, it's being depleted because we keep using more and more. It's fixed and we're depleting. C, no, there's plenty of renewable energy. D, both A and B. Think about it for a moment. Okay, are we running out of energy? A, the science is clear on this. B, yes, there's a fixed amount of energy and we're depleting it. C, no. D, both A and B. Okay, well, interestingly enough, the majority got this one right. The answer is no. There's plenty of energy. So why are we always hearing we're running out of energy, we're running out of energy, peak oil? What's going on? How do you reconcile these? I will show you. How much of the United States will need to be covered in these type of cells called photovoltaics or PV to power most of the energy, I should say the electrical demand of the United States? So for the United States, how much area would we have to cover with solar cells to power the United States? Would it be roughly a third of the entire country covered in these types of panels? A size that's roughly the state of Texas, which you know is a big state. About half the size of Texas, or an area about 65 miles on a side. How many say A? How many say B? C? Okay, D. Okay, well, the majority here has it by far. The answer is D. So now I'm telling you that we can actually supply the electrical needs of the United States by covering a fraction of the deserts in the Southwest with technology we've known about since the 60s. This, by the way, is the roof of the Tehama Clubhouse that I'll show you a little bit more in a few minutes. So I'm sure the question is popping in your heads, why aren't we doing this? If we can do this, why aren't we doing this? Okay. We'll come to that. Okay, one more question on energy. And this is perhaps the most important slide to remember, which is a hint, by the way, on the answer. So once you understand this will give you the big picture on energy. The amount of energy that comes into our system every day, okay, each day, comes from outside the system, like from the sun, is roughly equivalent to which of these four choices? The amount of energy we use in a day, the amount of energy that we use in a month, So in other words, we're getting in roughly 30 times what we need. The amount of energy that we use in a year, so that would mean each day we're getting in about 365 times the amount of energy we need. D, 10 times the amount of energy we use in a year. That'd be about 3,500 times. Or E, 1,000 times the energy we use in a year, which is in the neighborhood of 500,000 times the amount of energy we use in a day, comes in a day. Does everyone understand the question? How many say A? B? C? D? E? Okay, well, the correct answer, and I appreciate you all thinking this through, the correct answer, surprisingly, is E, and that's why this is so critical to understand. We get in roughly 6 orders of magnitude more energy than we're currently using. So that's roughly in the neighborhood of 1 million times more energy every day. It comes into the system whether we intercept it or not. Okay? So to say it in a very crass way, we are bombarded by energy every day. Our challenge is, do we have an effective way to use this energy in the form that it comes in? Can we convert it into something useful that meets our needs? But in terms of just total energy, which is expressed in different units like BTUs or ergs, or there's different units in different systems. But in terms of just total energy coming into our system, similar to the total water, we have an unbelievable amount of renewable energy coming into our system. So our challenge, your generation's challenge, my generation's challenge, it's all the same. How do we make use of that energy? And in fact, let me just give you an example. These are floodlights. You've all seen these outside your home. Okay. This is what people were using for decades. It's a regular, what's called incandescent filament, the regular light bulb. This is roughly 100 watts. That means it uses 100 watts of energy to give you so many lumens of light. Okay, then about 10 years ago, they came out with a fluorescent replacement. Same type of socket, same type of outdoor light. And for a similar amount of lumens, which is the amount of light you get, this uses 23 watts of energy. Okay, so now to get the same effect, instead of using 100 watts, I can now use 23 watts. Then, about 3 years ago, a new technology came out. Does anyone recognize this technology? LED technology? To get a similar amount of lumens, the LED, this one uses 5 watts. From 100 watts to 23 to 5. And this one, by the way, doesn't have any of that mercury problem. This one theoretically could be made to dispose and to reuse the parts. So technology, in many ways, has solved a lot of our problems for us. Because if we're using a lot of energy, and you just saw now we have 1 million times more renewable energy available. Now remember, most of our energy we use isn't renewable. It's that other kind of the stuff that gives us pollution. But if we switched over to renewable energy, the using of energy isn't inherently good or bad. See, right now, the politically correct terms are that if you use a lot of energy, you're kind of a Neanderthal. And the enlightened ones use less energy. Well, that's true when you're trying to get the same effect and you can do it with technology. Why would you use more energy? Let me show you this. This is a LED light. This uses so little energy, it just has batteries. Nothing to plug in. It has a magnet and places for 2 screws. And it has a setting that has a motion detector on it, which is located right back here. So now, for an outside light, where you used to use 100 watts, then the 23 watts, and now the 5 watts, well now, you could use something like this, put it on the motion-activated switch setting, put it where actually you want the light outside of your home, and you don't need electricity at all. Maybe plug-in electricity. You're using battery electricity. So it's now changing the way we think about like outdoor lighting. Because normally you had to put your outdoor lighting where there was a light socket. It may not be where you want the light. And so you're putting in big bulbs because you want to get the light from where the socket is over to where you need it. But now you can just take something like this and put it where you need it. You're done. You don't need a wired electricity. So technology can really change our way of thinking. Let me illustrate this. Now, when I refer to the last century, I'm not talking about 2000. I'm talking about 1900. So about 110 years ago, which of the following was one of the major problems? It's debatable whether it was the #1 problem, but it was certainly a major problem that people were constantly thinking about and plagued by. A, horse manure in the cities, Hitler taking over Europe, bubonic plague, all of the above or none of the above. Think about how you're going to answer. Okay, how many say A? Okay, how many say B? C? D, all of the above? None of the above. Okay, interesting. It was kind of evenly divided. The correct answer is A. Now, I know you're thinking like, well, I mean, that's not even on anyone's radar screen. Has anyone thought about this being a problem since you've been alive? Okay, nor since I've been alive. I mean, I saw it on Westerns when I was a kid. But remember, before the automobile, everyone went into the cities on horseback. And they would have their droppings, and there'd be a lot of disease issues. When it rains, how do you clean things up? And so with more and more people coming into the cities, this was becoming a real major problem. A two-dimensional solution could have been, let's hire a bunch of folks, follow the horses around with, little bags, and, solve it two-dimensionally. But we all know, because we know history, that this problem was actually, within about a decade, no one even remembered they had the problem. It was a three-dimensional technology solution to this problem, which was, back then, what was called the horseless carriage, or the first automobile. So the automobile eliminated this problem. Now, it created its own set of problems that we're dealing with today. But before the automobile, we had a huge problem. And technology transformed it. So what was a #1 problem can hardly even be remembered anymore. That's how far away we moved from what was considered the #1 problem in its day. Oh, by the way, this was a huge problem, but it didn't occur at 1900. It occurred about 1940. Bubonic plague, also a huge problem. About a third of the population of Europe was wiped out, but it happened quite a bit before 1900. And so, even though they're correct, they did not happen at that time. A little bit of a trick question. Okay, so that brings us now to today. What is our biggest problem today? I told you what our biggest problem was 110 years ago. Biggest problem today. Here are our choices. 5 choices. I could have made the list longer. I could have made it shorter, but I thought 5 is about the right number. Okay, so let's just briefly discuss these. First choice is carbon dioxide leading to anthropogenic and irreversible climate change. Okay, again, those terms mean anthropogenic, meaning man caused by mankind. Irreversible, meaning we're heading off a cliff, so to speak. Okay, B, shortages of resources. Very loose term. Any types of resources. Food, water, oil, coal, natural gas, uranium, wood, silicon. C, too much waste. All the plastic water bottles and diapers and all the stuff you hear about. We don't know how to get rid of our waste. So it's going to pile up and overwhelm us, and that's our biggest problem. D, human population growth. Just keeps growing, and one day, as that, there's any trekkers here, there was a Star Trek that showed everyone standing next to each other on the planet Gideon. Familiar to anybody? Before your time. Anyways, a very popular theme in the 60s, and in fact there was a famous book by a professor named Paul Ehrlich called The Population Bomb that predicted that very thing, that we're actually in geometric population growth, and pretty soon we're all going to be competing with resources and standing shoulder to shoulder, and very grim. Or E, human evil, whatever that is. Okay, so think about those for a moment. I mean, this is a big question. Biggest problem facing us today. Okay, everybody know how you're going to vote? Carbon dioxide, leading to irreversible climate change. Okay. B, shortages of resources. Okay, that's not a popular one. C, too much waste. Don't know how to get rid of the waste. Okay. D, human population growth. Okay, and E, human evil. Okay, interesting. Well, it looks like the winner was human population growth followed by too much waste. Now again, people can differ on what they perceive as the major problem of the day. In my opinion, by far, there's one that stands out from the rest. My opinion. And that is E, human evil. And the reason is, every one of these other problems we have solutions to. They may be serious problems, but we have solutions to them. The problem with human evil, not that I can define it well, hopefully you all just know kind of whatever that is. We don't have any ideas on how to fix it. All we know is that in every generation in recorded human history, it's existed and it's caused a lot of terrible suffering and harm. But it seems to be in every generation, and we don't have any idea how to deal with it. Every generation fights it to some extent, but we don't know any technological fix. All of these others we have fixes for. We can engineer products so that they have cradle-to-cradle life cycle instead of what's called cradle-to-grave, which is leading to the waste problem. Resources, we already talked about some of them, like water and energy, and we'll talk about those a little bit more. Carbon dioxide, we're going to talk about that also. Human population. Well, when I read that book, I was just a kid, and it scared the hell out of me. Paul Ehrlich's book, because it showed a geometric graph showing how quickly the population will keep doubling, and it's very frightening. Graphs can be very frightening, by the way. The one thing the book got completely wrong is that we have an actual cure for human population growth. And it's different than what you're thinking. You're thinking like birth control or whatnot, which actually is part of it, but it's the thing that you can actually track with no exceptions is that every single first world country has stable or declining populations. The ones that are growing rapidly are third world countries. That was not in the book. So now that's just an example of a solution that we have. And for many other reasons, like having the fresh water to drink, we're needing to help countries go from third world to first world to help solve some of those other problems we talked about. Fresh water, renewable energy. So I just put it out there that it's possible some of these problems will self-resolve themselves as parts of fixing other problems for a variety of reasons. Okay, so now that we've kind of set the stage, types of problems, past problems, the big picture of energy and water, renewable energy, what time period are we living in now? Are we living in one of the worst times to be alive? One of the best times to be alive? It's hard to tell. Some things are good, some things are really bad. Or we're pretty much at the end of times. Okay, think about how you're going to vote. How many say this is one of the worst times to be alive? Okay, how many say this is one of the best times to be alive? Okay. C, it's a kind of a mixed bag. And D, that we're really running up against the cliff. And again, there's room for opinion on this. I can tell you again, my opinion by far, I choose B. I think this is such an exciting time to be alive. I mean, just giving you some of these examples of technology changes, I mean, the opportunity that's there for every one of these problems, and by the way, whether the problems are real or perceived problems, in a way doesn't matter that much. Because if someone perceives a problem and they're acting in a certain way, well, that's still a problem that has to be solved. You have to fix the perception. That's an opportunity. Versus fixing something physical or real. That's an opportunity. So whether problems are real or perceived, there's opportunity. Okay, you're all going to graduate college. And if you had to pick one of these as your main goal after you graduate, you want to work for some type of nonprofit or government entity because there's something in the profit motive that is negative, this greed thing. B, follow your passion, whatever that is. If you feel it, go for it. C, find the things you have a special ability for and match that to a passion that leads to this thing that I haven't defined called goodness. Or D, pretty much the opposite of A, make money. Okay, everybody know how you're going to vote? A? Wow, no takers for A after that lead-in. Okay, how about B? Follow your passion. Good. C? Okay, and D? Okay, I appreciate the honesty there. You could probably tell them how I worded the question, that C is the one that I believe is the match here. I actually believe that B is bad advice. Because we can have passions that are either positive or negative. So if you have a passion, I don't believe we should follow every passion we have. I believe that's bad advice. I believe if we have a good passion or a passion that leads to goodness, and I have not defined what that is, but just work with me for a minute, that's different, and that's a subset of all the passions that we have. And I've heard a lot of graduation speeches, and I've heard this used a lot, and I cringe in my seat every time I hear it, because as human beings, we have thoughts enter our heads all the time. And it's easy to become passionate and obsessed with a thought, but it may not be a good thought. So it's a very, very dangerous thing to get too far out on that limb. But since I mentioned goodness, let's just talk about that for a moment. And again, I'm not defining it, and I'm not defining evil either. I'm just putting it out there. But whatever goodness is it something that can be legislated? Meaning, can we create a law that says you must do something good? Or do we only have the ability to create laws that tell you what not to do? You get the distinction? You know, like do not murder, it's telling you what not to do. But take the old lady across the street, that's telling you something to do. Okay? So can we create a law mandating you to do good? And here are the choices. Yes, you can. You just say, okay, everyone, when you see the old lady, you got to walk her across the street. Or B, no, because if you create a law saying that, then it has to have a punishment if you don't. And you could then put somebody in jail because you didn't take the lady across the street. I'm using a trivial example to help make the point. Well, you go to jail for also stealing. So now you're equating not doing good with doing bad. So because there's a punishment involved with legislation, the only way you can require good is you're trivializing bad because of the punishment part. Or C is just kind of the cop-out, getting lost on the word definition. Don't vote for C. Okay, so of the two choices, how many say A? Okay, and how many say B? Okay, and I agree with the B. We can do it, but not without making bad things less bad or having a lot of people in jail. And again, I use jail as just kind of the general what happens when you do something wrong. And this is problematic because how do governments get us to do this thing called goodness or the good passion? Well, how do we even figure out what that is? Okay, let's just pick out a reference at random here. Hopefully you've all heard of the Ten Commandments. This is not a class on theology. But of the Ten Commandments, there are what's called positive commandments and there's negative commandments. I'll give you an example. One of the negative commandments, I said a moment ago, not to murder. Okay, that's telling you something you should not do. That's a negative commandment. So, if you're familiar with the Ten Commandments, or even if you're not, guess as to how you think they are split up here. Do you think all of them are positive? All of them are negative? I just gave you a negative one, so we know that A cannot be correct. Because I gave you one of the actual commandments, so that's a negative commandment. 8 are positive, 2 are negative, 8 are negative, 2 are positive, or they're split 50-50. So we're going to skip A, because that's the wrong answer. How many say B? Okay, how many say C? D. All right. Or E, 50-50. Okay, well, it's interesting that the answer is 8 are negative and 2 are positive. So if you were to say, well, okay, I'm going to try to figure out this evil and goodness stuff by following the Ten Commandments, well, you would have 8 thoughts, 8 concepts on what not to do. Not to steal, not to murder, not to covet, another word that I'm not going to define. But there's only 2 that tell you what you should do. Anyone, by the way, know what those 2 are? Honor your mother, your father, and your mother. And the other one is? Observe the Sabbath. I heard somebody say, somebody got it there. Those are the only 2 positive commandments that tell you something to do. And you might be thinking, well, is that enough? Does that give me enough guidance on how to head towards goodness? But because it's not a theology class, I cannot answer that question. But I will give you one more biblical question because this helps with the answer. You all know the story of creation, book of Genesis? Okay, these are the four choices. Which was created first? How many say sun, moon, and stars? How many say light? Man and woman. Tree of life. Okay, well, most of you got it right. The actual answer is light. So think about it for a moment. How do you create light prior to the sun, the moon, and the stars? Because most of us assume that the light that was created was the sunlight, correct? But we know absolutely from the story. Again, this is a story. I'm not talking about science right now. But I'm saying in the story, light was created before the sun. What light could this be? I'll suggest to you that the light that was created ties in something with the goodness that we're not defining. Is anyone here a science major? Okay, I don't expect any of you to know the answer to this, but let's give it a try. Fundamental forces in the world today. How many fundamental forces exist that we know about? Here are the choices. How many say A? How many say B? How many say C? Over 100? None of the above. Okay, well, I'm impressed. I think the top vote getter was correct. 4. So hopefully you're putting some of these thoughts together. We talked about renewable energy. We talked about that we don't know how to get rid of water, and we can make it and combine the raw elements together. Of these 4 forces, there's gravity, electromagnetism, and then there's 2 forces we just give names to. We don't even know exactly what they do. I mean, we can describe what they do, but we don't experience it on a daily basis. They're called the strong force and the weak force. They're in the atom. The strong force keeps the protons together in the nucleus. They're all positive charged. Positive charges should burst apart, but something holds them together. That's the strong force. The weak force is the electron should be attracted to the protons, but it keeps flying around. So we give it a name. There's a weak force that keeps it circulating instead of combining. Those forces are like orders of magnitude more powerful than the ones we experience, gravity and electromagnetism. So of the 4 forces, we kind of know gravity, which is the weakest force. And electromagnetism is kind of what we're playing around with our little technology. And the 2 real big powerful forces, we just like have names for them. That's our state of development right now. And by the way, probably in your lifetime, the answer to that question will be 1. They believe that they're looking for a unified particle that will explain everything, but we haven't found it yet. So today the answer is 4. Okay, last few comments on sustainability. You've all heard this phrase. You can save the planet by changing a light bulb or not using a plastic bag. Has everyone heard the statement or something to that effect? Has anyone here seen the Al Gore movie, Inconvenient Truth? Okay, I think this is mentioned in that movie. Okay, here are your choices. True statement. Not true for a single person, but if everyone did it, it would literally save the planet. C, it isn't true, but it wasn't intended to be taken literally, or D, it's a false statement. How many say A, true statement? How many say B? Okay, how many say C? Okay, and D, false statement. Okay, this one's a little bit tougher for me to tell you the right answer. It's somewhere between these. I mean, really, I think the answer is D, but I like the sentiment, so I want to extend it and say, well, all right, maybe if we all did a bunch of things, it would help. But clearly, it helps us in our behavior, and that's important. So where's this leading? Is anybody aware of this? That in fact, I heard this first at a talk given here at CSUMB by Dr. James Lovelock, who wrote the Gaia series books. Has anyone heard of the Gaia books? This is where I first learned about it here, like 3 years ago. And it turns out, in fact, this one I'm going to tell you the answer on this one. This one, it turns out that President Obama is considering implementing this plan through his science advisor, Stephen Chu, that it's a serious option. It was actually in the paper not a month ago, that it's a serious option. And it is to heavily pollute the outer atmosphere of our planet so that sunlight is blocked from coming in. And the thought by these top scientific minds is that if we block sunlight, then that will forestall global warming or climate change. And again, this one I'm just going to tell you the answer. Again, my opinion of the answer, which is that C and D are what I believe is true here. When mankind starts to think that we are all powerful and we start to do these huge engineering projects like blocking sunlight with... When I was a kid, we used to have the really bad pollution, the sulfur dioxides. You don't have them anymore. We got rid of them, essentially, in the United States. But when I was a kid growing up in Los Angeles, you couldn't take deep breaths. I mean, it was really bad pollution. You couldn't see more than 2 or 3 blocks. LA is much cleaner today than it was when I grew up there. And that's the kind of stuff, the real bad polluting stuff, the sulfur dioxides that actually damages humans and other living things directly, measurably. And it will cut down sunlight. There's another idea of heavily polluting the oceans with iron ore that they believe could create plankton blooms and thereby sequester carbon dioxide. In my opinion, very dangerous ideas. I'm not nearly as worried as I am about climate change as I am worried about mankind's response to climate change through these types of ideas. And I would urge you to learn more about these, and if you want to speak out on issues and make a statement, those are the types of issues that you should really be talking about, because that's our common future. And if we screw it up, because we have the ability, we are so powerful, we have the ability to actually purposely screw up our planet, thinking we're solving another problem. And I know others could disagree with that. That's an opinion. Okay, just a few more, and then we'll move to a very different topic for just a few minutes. Carbon neutral and reduce carbon. Have you all heard this term? Carbon neutral, we need to be carbon neutral. Okay, are clear and the need is imminent? Probably a good thing to do, since carbon, the scientists say, is a very bad thing. C, incorrect and should not be used. Or both A and B, that we need to be carbon neutral and reduce carbon for these reasons. How many say A? How many say B? C? D? Okay, so C and D were the big winners, and they're, of course, exactly opposite. So that's good. Okay, this one again, in my opinion, the answer is absolutely C. And here's why. You are all carbon-based units. I'm a carbon-based unit. Every single thing you eat is carbon-based food. If we use the shortened term, we need to reduce carbon, or we need to become carbon neutral. Carbon is like one of the most wondrous elements on the periodic table. It's the one element common in all life on the planet. But we use this term, reduce carbon. We don't mean reduce carbon. We mean something else, but we say reduce carbon. Well, literally, reducing carbon could mean getting rid of people, or not growing food, or chopping down trees. Well, obviously, that's not what anyone means, right? By saying reducing carbon. But if you take it literally, I mean, this in what, a year's time has become like the catchphrase? And we're not like thinking about what is it saying? I mean, some dictator could take this term and say, oh, I'm going to reduce carbon. I'm going to try to wipe out so many millions of folks. I'm sustainable. I mean, I know it's a silly example, but I'm just telling you, this is not the right message. However, here are some choices that might be a better choice. When we say reduce carbon or become carbon neutral, what do we actually mean? Do we mean carbon emissions or gaseous carbon emissions? Do we mean industrial scale emissions of greenhouse gases? And or do we mean the burning of fossil fuels and other carbon-based compounds? And again, to spare you all, I'm going to tell you that any of these would be more accurate. By the way, anybody know what a carbon emission is? Could a baby be considered a carbon emission? I think so. That's why gaseous is a little more accurate, because then at least you're not saying we need to stop having babies. It can't be misconstrued. So again, to be clear, the problem we have with energy, why energy gets a rap, is because of a bad reputation, is because a lot of our energy is from carbon-based fuels. The only way we know how to use carbon-based fuels is we burn them, we transform them from a liquid or a solid or a gas, in the case of natural gas, and we use the energy in that process, but it leaves over a residue. That's the carbon pollution. It used to be a very dirty carbon pollution. We've now cleaned up the fuel, so a lot of it is now just CO2. Same stuff that we're exhaling in this room. But that's what we're talking about for greenhouse gases. By the way, anybody know other greenhouse gases? You all heard of methane, right? Methane is a very powerful greenhouse gas. Some scientists have calculated that if we stopped eating cows and instead we ate kangaroos, and I mean this seriously, I know it sounds like a joke, but apparently kangaroos give off a lot less methane from their bodily functions. And the methane from cow gas, if you will, is a significant contributor to greenhouse gas, because methane is a powerful greenhouse gas, CH4, which is, by the way, the same as natural gas. By the way, has anyone heard of water vapor? Is water vapor a greenhouse gas? Oh, yeah. Has anyone suggested that we should get rid of water vapor? Mm-mm. What percent of the atmosphere do you think has water vapor in it? 1%, 10%? Well, it varies. It's highly variable depending on the water, but it can be anywhere from 0 to 40% of the atmosphere at any point in time. You know how much CO2 is in the atmosphere? You know the critical numbers that we're all looking at? 385 parts per million. That's 1/3 of 1 part per thousand. Okay, water vapor could be in the atmosphere 20% of the atmosphere. CO2 that we're worried about is 1/10, or I should say 1/3 of 1/1000th part in the atmosphere. So it's amazing that we as a scientific culture can measure these things. I'm just saying we need to be careful on how we interpret the data, and somehow we need to have wisdom to keep it all in balance. Okay, so just to wrap this up, has everyone seen this graph? I'm surprised, because this was like on the front page of a lot of newspapers. It's called the hockey stick graph. This is the graph that Al Gore had in his movie that tries to create a correlation with CO2 and temperature rise. And if you saw the movie, this is where he has the big scissor lift in the auditorium, and this keeps rising. It turns out that the true record might actually look like this. These look very different, correct? This one looks like we are running towards the cliff and about to fall off, doesn't it? This, by the way, is the same graph as that population growth that I read in the book, The Population Bomb in the late 60s. Same geometric growth curve right there. The point I'm trying to say is whichever one is right or wrong should not make, in my opinion, any difference in how you lead your life. Because your life should be led towards that good passion, doing the right thing, if you will, regardless of whether you think that there's this terrible fear out there tomorrow. In other words, you should, again, my opinion, you should not respond to take action out of fear. That is a motivator. And I might add, fear is the motivator that every dictator has used in recorded human history. I'm not saying this is done by a dictator. I'm just putting out a correlation that anyone can look up. It's history. But what if you were motivated to do good things because that's your obligation to do? It's to do good. That's why we were put on the planet. Maybe. I'm just putting it out there. Or is the only way that you can take action because someone told you if you don't, you're going to die tomorrow or the day after tomorrow? So we come back to this question, what is sustainability? I give two possible parts of the answer here. And I would have you ask yourself some of these questions. Because I know they sound trivial questions, but in this context, are they? Is having a child a sustainable practice? Okay, literally, the only way you could honestly answer that question is, well, does sustainability imply that there's a fixed human population, in which case every birth coming in has to have somebody going out? Is that what anybody means by sustainability? I don't think so. So we have to ask ourselves tough questions and be careful when we jump on bandwagons. You know, here I am, I'm on the board of a thing called the Sustainability Academy, and I'm giving you the message about the dangers of using the term to cover too many things. Because it can lead to wonderful things, but it can lead to terrible things. I think I covered this. We don't need to respond out of fear of death. We have the technology already today to solve our energy problem. Now, we're going to know better tomorrow and next year and the year after. So like the solar cells that I'm going to show you in a minute at Tehama, when we put them on 12 years ago, they were 10 watts per square foot, which is pretty good efficiency. But today, you can buy a panel that's 20 watts per square foot. We've doubled the efficiency in about 12 years of solar panels. Fuel cells 12 years ago, you could not buy a packaged fuel cell from a commercial vendor. Today, I can go out and buy a 5 kilowatt black box that has a fuel cell that's equivalent to if I went out and bought a 5 kilowatt generator. And again, a fuel cell is getting its energy from having water essentially reconnect. It's taking the energy out of that reaction. So I leave you with this thought, concluding this first part of it, and then I'd like to quickly run through showing you a few examples of what we did at Tehama, which will take about 8 minutes or so, if we have the time. We basically have energy everywhere. Has anyone seen this type of flashlight? The kind you shake? Well, it turns out that there's a law in electricity where if you have an iron core and copper wire, that by just moving the copper wire over the iron core, you create electricity. So someone made these little flashlights. They're like a couple of bucks. You shake it, you create your own energy, stores it in a little regenerative battery, and you can have light whenever you want it, for all time. I mean, the bulb might eventually wear out, but no batteries, per se. This is the Hummer version. You can come up and see these. This one you can actually slightly see inside. Coil of copper and a little iron core. The point being, there's energy all around us. We are in constant energy fields. We just need to think, how do we use these forms of energy? And we need less and less amounts. I don't need 100 watts now for light. I can use 3 watts for light. This watch has a solar cell below the surface. All I have to do is give this about 10 minutes of light each day, and it will power itself indefinitely, because the watch doesn't need much power. So as we lower our energy consuming needs, and we figure out how to use some of these low forms of energy that are around us constantly. I mean, do you know that we're on a planet that's rotating at a tremendous speed? Okay. I do want to mention that concept of cradle to grave and cradle to cradle. There's an architect named Bill McDonough who really helped to get that terminology out there. And for the waste part of this discussion, cradle to cradle is really a powerful concept. It means if you design something so at the end of its lifetime you can take the components and then they can be used in something else, you never have waste. We're changing the idea that you put it, when you're done with something, in a throwaway place. So in the future, the dump that we think of as the waste dump today will be the place where you separate out the core elements and it becomes now a new thing. Because remember, because we're not God, we don't know how to create ex nihilo, out of nothing. We can transform things, and then we end up with something else. So all we have to do is design things so that we can constantly recreate something to something. Right now we design it something to put in a stack of stuff. But that's just opportunity, right? I mean, that isn't hard, is it? Just we're not thinking that way yet. And lastly, I know I brought in a lot of different concepts of biblical things and energy and random thoughts, Star Trek, but it all ties together in my mind, because the more you understand that everything has a connectivity to it. Star Wars used the idea of the force that emanates in all things, but the more we learn from science, there's some type of connectivity. And the more you can learn about a whole variety of subjects, including human nature, how did cultures develop? What motivates people to take action? can you come up with ways to get people to take action other than fear or anger? Do we always have to use negative emotions to get people to take action? Is that the state of humanity today? Instead of taking questions, if I could just quickly show you a few things of how we implemented these into HEMA, and then that should wrap things up, okay, with everyone's indulgence. So let me just show you a few implementations of some things, just so you can see how some folks are working on some of these items and the results. And I'll go through this very quickly. This happens to be Clint Eastwood's project. It's actually just a few miles behind the university here in the hills. It's roughly 2,000 acres. If anyone has been to the city of Carmel by the sea, it's over 3 times the size of the city of Carmel. So it's a very large area. And on most of the buildings, we put renewable energy. We were the first large renewable energy purveyors in the central region of California. This building had it first. This is the clubhouse. It's a 33 kilowatt system. So that means at the peak 1 hour of the day, it will produce 33 kilowatts of energy, which is 33,000 watts. So if this was 100 watts, you would have 330 of these hugely inefficient light bulbs, or like 1,500 of these efficient ones. Pretty good amount of energy. There's a stone that's found in abundance on site called Carmel Stone. A lot of the city of Carmel was built with stone from that general region, and a lot of our buildings use the stone from the site on the buildings on the site, which, by the way, is like the definition of sustainability. You're using something from the site, on the site, and ultimately it will return to the site. You're never going to take Carmel Stone and take it to a dump, because it's from the site, it belongs on the site. It also happens to be quite beautiful. We did some interesting arches that you don't see everywhere. Has anyone been to the Earthbound farm stand off of Carmel Valley Road? Organic? You guys don't get out much, do you? Okay, well, has anyone been to Mission Ranch behind the Carmel Mission? Okay, a few more hands there. Well, we remodeled the Mission Ranch that Mr. Eastwood purchased and saved from demolition, and there were going to be condominiums that were supposed to be built there, but he bought it and asked us to preserve it, which we did. And there were a few units down here in the floodplain that were in disrepair. And what we did is we moved them on a truck out to Carmel Valley, and they became the Earthbound farm stand, and were in that state for many, many years until Earthbound did a major renovation a few years ago. But we basically gave the buildings a second life. But at the time, we were so far ahead of the curve on green building, the newspaper feature, because things involving Mr. Eastwood often get a newspaper article, the newspaper said that Eastwood was moving his garbage into Carmel Valley, whereas today it would be buildings are getting adaptive reuse from motel units to a farm stand. But at the time, it was still thought, no, when something is done with its use, you take it to the dump. You don't reuse it. That's like using trash. So we've come a long way just in 15 years. We put the driving range over the maintenance and garage. So it's actually the roof of a building that's subterranean, and it all has native grasses on it. We used a ancient concept of architecture called passive solar design. And is anyone going into architecture? So you're probably not going to need to know this, but there are ways to line up a building with how the sun's energy comes in each day. You know, the sun's energy is very predictable. We know where it's going to rise, at what elevation it's going to get depending on the season. which can tell you what latitude you're at. And if you design your building to take those flows in and to absorb the excess energy in the daytime and then to release it at nighttime, you can actually design building using what's called passive solar principles to regulate itself energy-wise, similar to how we would regulate ourselves. You know, you put on more clothing when it's cold and less clothing when it's hot, drink more water, things like that. That's a site plan view of the fitness center. We happen to have, for passive solar design for the northern latitude where we live, you generally need to open up to the southern view. It turns out that the southern view happens to be a gorgeous view as well, so sometimes you get lucky when you're siting and planning projects like that. We used a lot of recycled materials. This is a recycled roof. Getting a second life now as a new home in Tehama. All of our wastewater from the project we collect in pipes, and it comes down to this old barn. This was built brand new in 1997. We designed the sag in the foundation and the sag in the roof so it looks like it's been there 100 years. The tin on this roof was found up one of the canyons, and we gave it a second life as a roof. That's still there. We treat all the sewage and we turn it into reclaimed water, which then irrigates the golf course. Again, we use the Carmel Stone and a lot of pervious materials, meaning that you can have materials that when rain falls on them, the water goes right down into the ground instead of collecting and running off. And then we did at the time something that was quite new. We had collected seeds from trees that were in the project, and we germinated them from, actual seedlings that you then transfer into 5-gallon pots and 15-gallon pots and then 2-foot square containers. And they're all native genetic trees. So a lot of times when you are adding vegetation to a project, you go to a nursery and you're not sure where the oak trees or the pine trees come from. There's been a lot of recent science saying that you can bring in disease vectors from trees outside of the area, even though they look like the oak trees or pine trees here. So by having the native genetic stock used here, you eliminate that, that potential threat. And then we are the model project in the state of California for reestablishing native grasses. When we started this project, the scientific experts, who were all PhDs in biology, said that the damage to native grasses in California was too great and there's no way to reestablish them. The damage is irreversible. We challenged that scientific belief and we became the model project in the state, and there's now hundreds of projects in the state. We were the ones who broke that bubble. And again, I don't mean to keep dinging science. I'm just saying, truth is truth. So, science many times comes out with a theory, but it's not borne out, and then science is supposed to correct itself and move on. That's the iterative process of science. But a lot of times these days, because science becomes politicized, it's easy to have an idea, and then everyone wants to jump on that bandwagon for political reasons, but it's no longer science. And we've dealt with this many, many times. This is just one example. And we have hundreds of acres of native grass restoration, and I might add, it's actually easy to establish native grasses. So it's not like you need a lot of fine-tuning and everything being just right. It's actually very easy and straightforward. We also helped bring a technology of relocating trees instead of a tree needing to be cut down if, like you're trying to widen a road or something and the tree's in the way or the road's in the way, however you want to think of it. But it used to be you just take out the tree. You gave zero value to the tree. And we came up with a system to actually move the trees. And it turns out that the trees actually thrive in relocated spots that match a similar type of terrain and grade and solar exposure. We've done this by the hundreds now. Here are trees that have been moved and are on a site where they'll be planted, and they have some time before they're planted to adjust to that microclimate that's right there. Here's an example of a tree that's getting moved and then planted. You can see that. And then one of the most interesting things we did is, you've all heard that when humans do something, they use resources and they kind of mess things up. And what we did on the water is a great example of how we turned that idea on its head. Okay, there's now so many folks who live and occupy in Tehama, relatively very low density. We have our own water treatment plant, and I already told you we collect the sewage, we reclaim it, and then we use that water for irrigation. But what happens about the water that we're using the first time? Are we mining a water resource? Well, the answer is no. What we did is we overbuilt our storm basins by simulating what nature naturally does. So, nature has creeks and ravines, and typically trees fall and they clog things up. So when the storm waters come, they're slowed down by what nature did to the creeks and ravines. But we're all taught in school, in engineering and architecture school, that no, you got to clean out all these channels so water can flow fast, because that's how we want to calculate it. We want to calculate a certain geometric volume. So what we did is we overbuilt the volume and then created an engineered solution to enhance the nature that's there by simulating tree falls, essentially. So all the stormwater that falls, we allow that to infiltrate into the ground instead of running off quickly. And in that way, we are regenerative from a water perspective. So in other words, because the humans are there, there's more water in the aquifer than if the humans weren't there. And that goes, I suspect, contrary to everything you've been taught and everything I had been taught, which is no, humans just consume. If there was X amount of water before we were there, there will be less than X after we're there. And the truth is that no, we have more water because of how we designed the system. And so with that, I was showing you more pictures of our treatment plant. This is where the reclaimed water goes. We came up with a unique way to build our roads so that we don't have to impact the forest beyond the prism of the road. And by the way, people always ask, well, to put in these walls, how expensive is that, to save that forest? And I always answer the same way, saying, well, tell me what value you place on the trees, and then I'll tell you how cheap it is. Because the question implies that the trees have zero value, and therefore it's expensive. But if you give value to each of these trees that might be 100 years old or 60 years old, well, pretty soon that wall's pretty cheap. Just depends on how you look at it. And of course, we want to be good neighbors to the people we share the land with. We have a very low density so that we can integrate in with nature and we can become of the land instead of being on the land. And basically our goal is to live in harmony. We have renewable energy in many, many places. We have a lot of places for the wildlife to get water. And our goal is to, like I said, integrate, lift that human spirit, that human sustainability, if you will. And with that, I think I will conclude and thank you for your kind attention.